Yeah, this is a little bit an old figure of the, showing a little bit of the history of the developments that's been in Norway related to fish farming. Well, we started in enclosed bay, and with cages very close to the shore. And after some years, we realized we also have very small cages, as you will see here. Is this working? Yeah. See here, close to the shore, and these bays we very soon learned we couldn't have enough portion for the fish. We had a problem with growth. And then we also had cages very close to the shore base, actually where the owner of the farm lived. He could walk on a walkway out to the cages, but then we soon saw we got sediments under the cages, we got sediments under the cages, we got poor conditions for the fish, and we had to move further away from the shore into deeper water to get better currents and better water exchange. And then we gradually moved into deeper water, and then today we are thinking about moving into the open ocean with the cages. And what also happened was that as we moved and developed the industry, we also learned that bigger cages are more efficient, they are cheaper per cubic meter or volume. So you see, we started with small cages of 40 meters in circumference. And why we use circumference and not diameter is because we bought pipes of 10 meter length and welded together. So with 4 pipes, we had 40 meter, with 6 length, we had 60 meter, and that's how easy to know what type of cage we talked about. So we see, we started with 40 meter cages back in 1970s, when I started in industry. And then as we learned to handle those cages, we moved to bigger cages. And by the late, around 2000, we had cages up to 120 meter in circumference, and also the nets become deeper. And we know with cages with a circumference of more than 60 meter, we need a boat to handle the nets. Then you can't lift the nets by just having a lot of people to do it. So you need more mechanized boats and bigger boats to handle the nets. And then we moved into bigger cages, as you will see here, and today there are cages up to 200 meter in circumference with nets of 25 to 50 meter depth. So they're really very huge, and you can see the volume. That's important. They had increased more than 200 times from what we started with 40 years ago. And then when we think about offshore cages, then what is an offshore cage? We have in Norway, after a lot of problems with the cages being damaged in storms, we developed a standard for cages, and the biggest cages, and that is based on the sites. So you have to do a study of the flats, the wave height and the currents on the site, and based on that you have to prepare the dimensions of the moorings and also the strength of the cages. And the biggest one are 2.5 meter significant wave height, and that is the basis. If you are bigger than that, you will have to, you may not even get the permits. So offshore, I said, has to be about 5 kilometers from the shore. You have a 25 kilometer fetch, and waves should be more than 2.5 meter significant wave height. I mean, the highest waves could be up to 5 meters. And the other interesting thing is, of course, access. How many days a year can you work with your cages? Is that just a long period with storms when you cannot work? Then that's happened in the offshore environment, and it's one of the challenges we have by moving into offshore cage farming. And we have tried in Norway, and this is this is not the Norwegian farm. This is a company I was involved in for many years in Spain, and this is actually off the coast of Spain, and it's about 200-300 nautical miles to Africa. So it's a very long fetch, and it worked very well for many years. It's still there working, And so it's a real, or close to an offshore environment. There are a few storms in the Mediterranean, and here we have had only one, which was a real hurricane with more than 30 meter wind speed, or more than 30 meters per second, and then we had a damage of 1 or 2 cages. But what is important, in addition to the cage structure, is of course how we keep the nets taut in the storm, and also the mooring systems. So this farm has been there now for maybe 20 years, and it's still working in the offshore environment with what I would call a improved standard technology. And then in Norway, we for many years dreamt about offshore cages and cages in more high energy sites, like this one that was designed in 1988, made of steel. It was a monster in those years, but it turned out it was a few of them were built, and one of them were moored off the island of Arran in Ireland, and in a big storm it actually moved 500 meters, and all the nets was washed onto the deck, and the fish killed, and the project stopped. So this is one of the problems we have in offshore cage farming. Actually, we have fish in the nets, and how do you keep the nets taut? How do you keep them in place in big storms? One is the structure itself, but the nets is the most difficult part of the system. And then there have been a few trials of other offshore systems, and this is an old it's a Swedish design that was tried for here and there around the world. For instance, in Scotland there were a few of these, Farm Ocean, and they tolerate a lot of waves, but they are very difficult to work with. We have another system, and I'm sure you will have Dr. Lisa talking about this today. It's a reef tension leg design, also been around for many years, but not really being what I would like to call a big success in offshore cage farming. And then I will move in and talk about a little bit about the developments we see in the salmon farming industry in Norway. This is the first, is a traditional way we do the farming. We have broodstock and in cages, we produce eggs, and then we move the eggs into the hatchery, in land-based hatchery, and when they are about 100 grams and smalls, we move them into open cages. That's how we have been working, and are still working for many years. But then there are developments, and in the open net cages that we have in the fjords and inside, let's say, along the coast, in sheltered areas, we see we have more problems with sea lice. The sea lice is taken from cage to cage by the current, and from farm to farm. We have also problems with fish escaping from the nets. That's a big issue for the government, that the fish escaping are mixed with the wild salmon, and they think there could be long-term genetic changes to the wild populations. And we have another issue that may come up, and that is the discharge from the cages. We do not collect the sludge or the offal from the fish, and that long-term, as the industry increases in Norway, may cause a problem. So what do we do to avoid the sea lice and the fish escaping? Well, there are a number of solutions, and the first one is you make the fish bigger on land, in the hatchery. You put in what we call a nursery, where you may farm the fish from 100 grams to 500 grams before you put them into the cages, or you may even produce them to 800 grams or a kilo, and then you shorten the time. You have the fish exposed to sea lice and other parrots in the sea in the open net pen. That is one way of doing it. The other way is to move them from the hatchery into a closed containment in the sea. That means you have a cage or a structure. It could be made of tarpaulins, it could be made of steel, it could be made of concrete, where you actually pump or push the water into the structure, and in that way you can keep the fish sheltered, should I say, from the environment around the cages before you move them into an open cage. So you have what we like to call it, a floating nursery before you move it into an open net. Or you can have them in that close containment to market size. That's the other option. And the final, solution would be to keep them in recirculating aquaculture on land to market size. So all these kind of methods are now being tried in Norway, and we don't know what would be the solution, but it's obvious there will be definitely higher investments, both in the nurseries and in the technology we are using in the sea. And the other interesting technology is that being developed is the hatchery technology, where all the new hatcheries and many of the old ones are converted from flow-through, where we use the natural water flowing by gravity through the hatchery. We now move into using recirculating aquaculture, and it turns out we have then much better control of the environment for the fish, and we also turn out it looks like a better quality smolt where they enter the cages. So this is a very interesting technology, but it's costing a lot more than a standard flow-through hatchery, so we like to utilize it as much as possible. That means a much higher fish density than we have in a traditional hatchery. So we then are moving them into tanks and grow them up to a certain size, and then we split them in 2 or 3, move them into other tanks and split again before we finally move them into the cages or into a closed containment, or continue to grow them in a recirculating aquaculture system. And this recirculating aquaculture is now in Europe being used more and more also for marine hatcheries, and I believe that's the future for growing fish to also in Asia in hatcheries is recirculating technology. And I think the other interesting thing, if we go back to my previous figure, is the nurseries we now have for salmon, growing them to 500 grams or maybe even bigger in land-based hatcheries. And I believe this is also the future when we look on offshore fish farming. I don't think we can put the small juvenile fish into offshore cages. We see by having a bigger and more robust fish when they go into nets, make it more likely to have success and a lower mortality and a healthier fish in the closed containment you have. It could be nets inshore, but definitely if you move fish offshore in a very exposed area, we think you should start maybe not with a 2 or 3 gram juvenile fish, but you should have it maybe 10 gram or 100 gram or maybe 1 kilo, and just keep it for a short period when you have the highest density in offshore cages, because the bigger fish will be more robust and withstand the offshore environment much better. And move on a little bit, and we can jump to Asia. And this is a project I'm working on in Cambodia, where we will have cages A and B inshore, and that's where we also will use initially to train people. And when we have been there a few years, we start for a period to move fish into what I call the sea offshore cages, which we believe with the technology we have today, we will only have the fish there in the dry season from, say, December to June, because in the wet season, in the monsoon season, there are very high waves, and it will be difficult to work. We know the cages will survive, but we also have to make sure we can be there, feed the fish, harvest the fish, and that will be difficult in this environment. This is about 12 degrees north in Cambodia. Oh, sorry. Yeah. And then I will just show a few examples when I talked about it. Now we are back to salmon farming, the closed containment. Yeah. Do you have only 5 minutes left? Is that the... Yeah. Okay.
It's going to
You
be more
have
time
one.
because the other speaker a little bit faster.
You've got time.
It's not we had to rush. Yeah, these are the close containment, and these are the developments in Norway. As you may know, we are not permitted by the government to increase the production before we have solved the industry, have solutions to how to handle and reduce the sea lice, how to avoid fish escaping from the cages. And they have not handed out any permits, except that you can get permits if you have a big development project that are going to address these two problems. So we have been very inventive and come up with a big number of projects, and they have to be big cost because you are able to get aquaculture permits if you succeed. And here are a few examples. One is a big, let's see. Here is one example. This is a big floating concrete structure. It's about 100 meters long and 15 meters deep, with a volume of 34,000 cubic meters. And the investments are high. This will cost about $12 to $15 million to build. But the operations will not be that expensive because we are not lifting the water. We are pushing the water through the structure. And by taking water from about 20 to 30 meter depth, we will avoid the sea lice. And of course, this will be like a prison. It's made of concrete, so the fish cannot easily escape. And then we have another structure that being tried. This is EcoMan. This is a steel frame where they have tarpaulins around to avoid surface water to enter the farm. And then again, they are pumping from deep water into the structure. And these are made for, what should I say, sheltered areas. And why we are pumping water from deep, from 20, 30 meter depth, is then we avoid sea lice. Sea lice is positive phototactic, is close to the surface, but also by pumping in deep water, we get a more stable temperature. And then we have another one you might have seen that will be very good at publicity. This is made of polyester and it's like an egg. It's the same principle, deep water in and then a close containment so the fish is protected from the environment. Again, this is initially, I don't think, meant to be offshore, but in areas in the fjords. And then there are also people who think that by moving offshore, we will avoid the problems with sea lice. And there are a few developments. Let's see now. Yeah. We lost the picture. No. In this one, there's a strange enough, there's a structure missing. Well, in Europe, we are building a lot of wind farms, and some of the wind farms is not just one windmill in the sea. There may be 30, 40, 50 or hundreds. It's big areas that are covered, and a lot of us has thought that would be a very nice place to do fish farming because there are no fishing. Fishing is banned in the area, and traffic will be restricted as well. And there have been a lot of research in Europe about how to use this offshore windmill areas for fish farming. And this is a book that was summarizing very well, if you're interested in that, multi-use sites, where they've tried to do mussel farming, algae farming, fish farming, oyster farming in between the windmills. The challenge is, of course, there are a lot of cables between the windmills, and the windmill people doesn't like other activity in the area, but the authorities think this area should be used for other things than just electric generation by wind. So what we see here, I don't know. The challenge is again that it's very exposed areas. It's in the North Sea. It's shallow, but there are certainly areas available for other users, hopefully long term. And multi-purpose is because they want to grow more than just one thing. And EU have a project, Tropos, where they looked into this as well, but nothing really happened when it comes to commercial activity. And this is the picture I missed. This is the one, as I said, Norwegian, instead of, as you say, close containment in the fjord. The other option is to move offshore. And this is a farm that's being built by SalMar. It's can farm about 8,000 tons of salmon. It's 60 meter deep and I think down to 100 meter wide. And it's been in operation now. It's built in China, with transport to Norway, and been in operation from October. And this is designed, if I recall it now, for something like 8 meters significant wave height, which will be in many places on the coast of Norway be okay, but not in an offshore environment. Outside the coast, with no shelter, or you may have waves that certainly took a wave height of up to 25 meters. That means you have a significant wave height of about 12, 15 meters. And this is how it works. So on the other picture, submerged, and they're going to harvest the first fish later this year. And of course, it's a little bit shelter where it is, and it has been working very well. And this is another one being designed. It's again for partly offshore use. It's about 430 meters long and 40 meters wide. And again, the plan is to have 8 to 10,000 tons of fish in this system. And again, to utilize a system like this efficiently, you can't stock these with 100-gram fish and wait for 2 years to harvest them. You will stock them with fish that are half grown, which is very important, so you can utilize maybe half a kilo or 1 kilo in offshore structures or close containment, and then you move them into a structure like this, because then you utilize the very expensive, the high investments are much better than you will if you are starting with a small fish. And this is one I was picking up from Aquaculture for Fish Farm International. This is apparently a Chinese design for 2,600 tons of yellow crude. And this is another that being proposed in Norway. This is not built, but it may be built. It's Ocean Farm 2. It's SalMar, the company that built the first ocean farm. This is twice the size, 160 meters wide, and you see here designed for 50 meters significant wave height, so that could be offshore in Norway, and 15,000 tons of salmon is what they think this could hold. And they talk about the cost of 1.5 billion Norwegian kroner. That would be $200 million for this structure. And the first one was actually costing about 100 million to build the first ocean farm one. And this is another offshore dream, where you have a big concrete ring, you have windmills on the top, and then you have conventional cages inside. If this ever will happen, I doubt it. Anyway, there are a lot of plans and conceptual designs being put forward in Norway. And where should you then locate offshore fish farming? And there's one place where you do not need it, and that is where we are now, in parts of Asia, where we have the technology, because if you are between 10 degrees north and 10 degrees south, you have very few hurricanes or typhoons. The risk of typhoons are very low. So the technology we have today with proper cages, proper moorings could be used here. It's when you move north of 10 degrees north, then you are a high risk of coming into the typhoon area or hurricane area you have around the globe. So this is where you need real offshore technology. So I can tell you about that, but there isn't time, so we move on. And what we see in Norway for cage farming, even in the fjords, it's expensive to have people on the cages, and also the control systems become more and more expensive, so we now try to centralize them, so we have wireless information pictures going from the cages to someone sitting on shore and doing the feeding and controlling what happens on the cages. And I think the same we will see when we move offshore. There will be very few people involved. They will be controlled like they do in the offshore industry, offshore oil industry, where you have a big, today, no floating structures. Actually, you have the installations on the bottom, and then you have remote control of the oil pumping and all the gas production. And this is a picture where you show all the remote sensors you can have and how you do the signals go to the control center on shore from where you control your offshore production. But of course, if you think about the robbery or problems, of course there will be no people there to stop any coming there to take your fish, but that's a different. So what species can you farm? And I looked here, made a list of what I think most of these fish, except the groupers, you could farm in theory in offshore cages. But as I say, what you need is a very good supply of juveniles. So you need actually more or less an industry that can supply you juveniles and half-grown fish. So you are sure you can stock your cages all the time. And this is a challenge, to have eggs available, juvenile production running also say 12 months a year and not only part of the year. So, and here you see there are some species like tuna, it would be very nice to do in offshore cages, but where do you get the juveniles from? They have a limited production in Japan and very few other places. And you say to the yellowtail or the snappers, they are limited production of juveniles. And you have the groupers where there's limited production of juveniles, but also I don't think they do well in offshore cages anyway due to their behavior. And then your cobia, one of my pet fish. It's a very interesting fish to farm, but there will be limited availability of juveniles. This is me and my cobia. And this is what I think will happen when we develop an industry, like, should we say, offshore fish farming and mariculture. We will start with high costs and hopefully also high price on the fish. And as the industry develops, we will be able to reduce the cost. We pass that on to the consumer. We expand the markets for our fish. And this is what happened with salmon farming. You see in the early days we had high cost and also high price on the fish, but with the green line you see how the production has increased, and we have been able to get economy of scale, reduce the cost, pass that cost or reduce price or cost onto the consumer, that way eating more salmon and that way expanding the markets. So I think the future in offshore fish farming will be this. What's very important, as I pointed out, is the supply of juveniles or small fish, either from hatchery and from nurseries that I believe will be offshore or onshore, sorry, and in recirculating technology, or from an inshore cage before you move the fish to your offshore cages. And remote sensors will be very important, and we will see remote control of the offshore farms. We talk about self-driving cars, but I think we are working on with self-autonomous boats that even a lot easier. There's not much traffic at the sea. So I think we soon will see these offshore cages. We operate with our autonomous boats that move from the shore to the structures we have offshore. And also I believe that we will see that there's a great future for if the cost is right. And the cost of production, and we talk about feed and people, may not be higher than inshore, but it's the investment in the structures and also the boats, how you service your cages offshore. So again, then you need volume to reduce your cost. And with volume you have also it's important to keep in mind the marketing of the fish, already been mentioned. It's fine to produce your fish, but you have to make sure you have a consumer who can afford to buy it too. But I think we soon will see more and more cages being offshore, and I look forward to what will happen and what we have at this conference. So thank you very much for listening.